next talk, which will be actually reasonable to do so because our next speaker is also working in the area of mathematical modelization. Jean-Marc, are you ready?
Yeah, I'm ready.
Yes, so let me introduce our next speaker, whom you have already seen yesterday during his term as the chair of one of the sessions. He is also a fluid dynamicist, applied mathematician. He is one of the first who have used serious mathematical computing numerical approaches to solving mathematical problems, and one who has always had the thesis that Dimitrios has so nicely explained in his talk, that we cannot solve mathematical problems but by brute force, even if we do use a computer, and has in his work tried to find the balance between using the computing power and the intelligent modelization of mathematical problems. So his talk is entitled War, Peace, COVID, Racism, Happiness, and Newton's second law of motion. Please, go ahead.
Thank you very much, Mirna, first for the invitation and for all these very kind words. As Mirna said, I'm also an applied mathematician. I work in an area similar to the one that Dimitrios worked in. And in fact, over the years, we did collaborate a lot and wrote together quite a number of papers. Particular, what I'm doing is related to mechanics, more precisely fluid mechanics, like in Dimitrios' talk. For example, propagation of waves at the interface between two fluids. The problems are that we investigate are non-linear problem in the sense that it's not possible to write a simple answer in an analytical way. And therefore, these problems have to be solved by either numerical simulation on the computer or by deriving approximate asymptotic solution. And in these problems, in mechanics, in fluid mechanics, much progress has been achieved over the last few hundred years. There are still many open questions, but there's been a great success over the years. And what I'm saying here is quite related to what Dimitrios was talking about, in the sense it complements it. This great success is based on the fact that we have basic laws. Like, for example, Newton's second law, force equal mass multiplied by acceleration. If in our problem of wave propagation, we want to introduce the effect of electrical fields, for example, then again, we have very good equations, which are the Maxwell equations, which describe electromagnetic waves. And something like the Newton's second law, force equal mass multiplied by acceleration, is an extremely good basis to a derived model. It's maybe useful to mention that it is not exact. There are better models in which we can put a better law, on which you can put, for example, corrections due to relativity. But in most applications that you would do, you can neglect this contribution because you have velocity which are much smaller than the speed of light. And if you want to model what happens when you drive your car on a highway, even if you're speeding, you can definitely neglect relativity correction. Similarly, the model, and again, I want to say it's not a purely exact model, but it's an excellent model. For example, if, as Dimitrios described, you want to describe the motion of planets or divides orbits to go to the moon or something like that. And what we want to do is, in fact, now to model more complicated things like COVID-19, as Dimitri described, they are excellent models, but it becomes already much more complex. Now, we want also here to discuss how to plan the future, to try to get to a better world and see if maybe mathematics and modeling can help in that case. So what we want to do in that case is to, in fact, model society, model then how people behave. Try to predict if a peaceful demonstration is going to evolve into a riot. Try to see what would be the effect of a political decision. Is it going to be helpful for the people? Will people like it? Is it going to generate strikes and so forth? And now when you move to that, the first observation is that to model society, to model politics, we no longer have Newton's second law. We no longer have Maxwell's equation. We don't have basic equations. So the modeling becomes much harder. Often modeling in these problems try to mimic what we do to physical problem. Like in physics, we might have a classical partial differential equation, which is a heat equation, and which describes the diffusion of heat in a medium. And then we can try to use this diffusion model, maybe to model different things. I don't know how fake news propagate into society. Try to mimic what we do for physical system, but it is no longer based on basic laws like Newton's second law. Also, this main heat equation appears in other area, like in financial mathematics. It will appear, in fact, in the form of the Black-Scholes equation for pricing options. And what we would need to move to that is somebody to discover Newton's second law for society, for political ideas, and so forth. So when I was preparing the talk, then it occurred at that stage that the situation is not that simple. Because even if we discover the Newton second law, basic laws, solid laws on which to build our models, the model that we will develop will only produce, in fact, rational ideas, rational thinking. Like rational thinking would be similar, still similar to what we have in physics. If we have a particle, we will specify the initial velocity, the initial position, and then use the equation of mechanics to, let's say, predict the trajectory, taking into account the forces which are acting on the particle. Maybe a political equivalent of that would be that the initial position might be the previous history in that particular domain. The forces would be the decision that we put in the model, and then use the model. And the model is going, in fact, to predict something in a rational way. And what is disturbing when we look at things which happen in politics, in history, we don't see that things are that rational. Take the example of the Cold War. During the Cold War, there was a theory, which is the theory of deterrence, which essentially, maybe caricaturing a little bit, the thing is that we're going to produce more and more atomic weapons, and the more atomic weapons that we have, the better it is, the more stable the situation will be. I think it will be very difficult to have a rational model which would predict such a kind of conclusion. Other things that I put as an example, which happened years ago, it was the war in Iraq. If we look at it at the time, the US and the UK went in the war to look after the weapon of massive destruction in Iraq that they never found. So if we try to put that in a model, it's something that the motivation for the war doesn't seem to be real, and it's hard to see how a model could predict these kind of things. Another one I was, but I don't want to talk to go into something politic, but we have a world leader, for example, we put every day all kind of ideas on Twitters. It would be very hard to have a model based on something rational, which could predict all the various things that they put on Twitter, which sometimes, at least to me, do not seem to be all that rational. Other things which occur over the years are, for example, the religious war in the 16th and 17th century between Catholic and Protestant. What's the rationale behind that? For most people, it is not, I'm not a religious person, but it's not an obvious thing. What is the difference between a Catholic and a Protestant? What is a philosophical difference from that? But still at the time, I checked that this morning on the web, 11 million people fought and died for this religious war. And I doubt very much that these 11 million people, that among them, many people knew the philosophical difference between Catholic and Protestant. So this thing seems to be, lot of things seems to be, in a way, kind of irrational. It seems, I wouldn't know how we could model these things mathematically. We can do things, but we need also to find some simple solution to add to the mathematical model. And this simple solution would be to avoid irrational things. And because if we have these irrational things, we cannot really model things. One of my a simple idea is something that I did remember also preparing the talk about Jean-Jacques Rousseau, things that I things to remember from high school. I'm going to cite it from the top of my head. What Jean-Jacques Rousseau thought is that people, in fact, were naturally good, naturally just. And that's the problem of all the thing which happens, is because people then get corrupted by the society. Seems a very naive idea, but the example that we proved before, this irrational thing, seems to indicate that there is an abuse of the populations by the leaders, that we try to make people believe, or they try to make people believe in things which do not exist for selfish reasons, often difficult to understand, maybe to be re-elected or something like that. So the responsibility of the leader comes in many things. In previous talks that we had yesterday, we talked about the planet, about the ecology, and there also there is an enormous responsibilities of the leaders, of the capitalist leaders. Over years and years, we hear that it was important to consume. It was important to buy cars, not just one car for the family, but maybe 3 cars for the parents and for the children. And these things are things which are, I believe, forced on people. It is not something which is natural. It's a corruption of people. And maybe a proof of it is that to force people to consume, it is necessary to advertise a lot. People naturally maybe don't want to consume that much if they're not really brainwashed by all the ads which are all over the place. But the ads which are there to create artificial needs, which in fact do not bring satisfaction. So I'm not saying here that we should go and live back in caves, but we should think about that these artificial needs, in fact, do not bring happiness. People were forced to drive cars, so people can go and drive the car for an hour, being alone in the car. Does that bring satisfaction to be alone in the car, not to be able to talk to anybody? So it's a lot of questions like this, for which we can find, in fact, simple solutions, and also small solutions, which can be very effective. On my profession, I do two things. I do research in mathematics, in applied mathematics, and I do also teaching. So teaching, I did, in fact, taught students from all over the world, from Europe, from the US, from Australia, from Asia, from Africa, all the students from all over the place. The teaching that we do, in fact, can bring to the people, to the new generation, the basic idea of intellectual honesty, the idea of generosity, by the way we present things. Certainly the intellectual integrity is something which is very big in that. So this seems maybe a little vague about teaching, but I'll quote something again from memory that I wrote when I was an undergraduate student. I was reading a book on the waves. I think the book was written by an author called Kingsman. I seem to have misplaced the book. But at the beginning of the book, he had this observation, this quote. He says, nobody can say, I educated him or her. It is a proud thing to say, I taught him or her. And it is a wise thing not to say what. All this, I'll leave the thing open to discussion. These are a few thoughts about the future. And,
thank you very much, Jean-Marc. I think one aspect that is missing and was in your title, you were talking about racism. Do you want to say something on that?
About?
In your title, there was the word racism, and you didn't say.
Racism.
Yeah,
yes.
I thought, yeah, the racism about that, of course, we've been talking and thinking a lot about it because of the event in the US. But I think that there is also a responsibility of leaders, all kind of leaders, in particular also leaders in the church, in the various churches which are there. Racism, of course, again, is the question I would put. Is racism really inside people, or people, in fact, through these leaders, become racist? I'm personal experience that I had many years in Australia with a very good friend, a very, very intelligent woman who wrote a very, very good book. We were having dinner, and it came in the conversation that I'm a Jew. And then there was a silence there. And it's a very educated person. And she said to me, but how can you live? You have killed God. So that kind of thing is not a natural thing in people. People must have taught her these things, maybe teachers, maybe people in the church. And there is, maybe, I don't know, maybe there is racism, maybe Jean-Jacques Rousseau is not right, maybe there is racism in people, but it's certainly increased by the lies of certain leader.
Yes, thank you very much, Jean-Marc. Well, you know, I know why I'm with you. Are there any questions that people would like to ask Jean-Marc, or comments to make? Andres, you didn't put your microphone, sorry.
Oh, okay, yeah, thank you, thank you,
okay.
yeah. So at some point, Jean-Marc, thank you very much for your sharing your thoughts. There was this switch you described, going from, you know, your study of fluid dynamics and you know, all the methods there are and so on. I remember a conversation with you many, many years ago where we were describing what is the right equation of a drop of tea in a tea kettle or something like that. That was incredibly complicated. And then you go from there to, you know, which is already incredibly complicated, to modeling society. And, you know, looking at society as some kind of a enormous, you know, fluid of some sort where people, you know, can be made to go right or left, or maybe crazy or something, or and then you mentioned the way it is happening now. This, you know, this brings a conversation that is also connected to Menachem's remarks after the previous talk by Demetrius. There is this, possibility. There is this, optimism of science on the one hand, of being able even to mold something as complex as society, perhaps. Yet at the same time, there is a warning of of all the danger. Let me just mention in connection to this. So Imperial College has been kind of at the center of this of the pandemic discussion, and here some economists and who believe in the role of game theory in a kind of, I think, naive way in a country, they have been now attacking what they call the imperial model, the naive imperial model. I don't know, there are people who are close to politicians, there are people who are close to politics, but it's an example of what Menachem was saying, of this sort of belief, disbelief, and warning against the excess of science. So going back to your fluid dynamic, can you say more, about the dangers of this extension of ideas going from fluid dynamics to dynamics of society? Because we see, a lot of serious misunderstandings happening all over the world, and especially around the imperial college model, so forth.
When you do things like fluid dynamics, and let's say model common fluids like water and air, you have very solid equations. In fact, they were written by Demetrius in his school. He says a Navier-Stokes equation. This is what is a Navier-Stokes equation? It is in fact Newton's second law, but applied to a continuous medium. And with that, we can. It's not easy, but we can derive very good models. Now, you said also in your comment, we have society, and maybe we, well, it's the same way that when you have a fluid, you don't want to follow all the molecules. If you have a society, so many people, you don't want to follow everybody. So you're going to model it as being a fluid. But you don't have the Navier-Stokes equation. So you'll have to devise some models. And well, people have done that. There's some limitation because there are a lot of different models that you can do. And so that's a limitation that we have, not to have the basic laws to describe society.
Mm-hmm. Yeah, I'll say something too, because this discussion that Demetrius has started and you have completed, as Giselle says in her comments, brings us to the idea of mathematical modeling. And from what I know about mathematical modeling, we basically have three types of models. One are the continuous models that you were discussing. Another one are discrete models where we use graph theory and game theory that Andres mentioned, and he mentioned some people who are using that. The third one is logic. I will be talking in my talk about logic.
Mm-hmm. Yeah.
And of course, here we are logicians. Well, I would like to really stress this, something that came from your talk. Our models are good, but they have assumptions. I think this is something which is true not only for the models that you and Dimitrios described. This is also true for the models that use game theory. It is also true for models that use logic. All these models are good, but none of them is perfect. And it is very dangerous that some people should be using them in a way that implies that they are perfect. And perhaps there is only a small part of the audience that doesn't already know what I'm going to say, but I'm still going to say it. An example of a model going wrong is what John von Neumann was doing. It's very interesting to read how game theory was developed by Morgenstern and von Neumann. And it's also important to add that using game theory to model human behavior was very noble at the time that von Neumann started thinking about that, which was at the time that he wanted to save the world of the Second World War, to save the people from Shoah and the other destruction of the Second World War. But then it went berserk. He himself went berserk and went developing bombs, throwing them on everybody, suggesting to the government with all the power that he had to go and bomb, because if we don't bomb, they're going to bomb us. So scientists, unfortunately, can find themselves in the situation that that they abuse their own knowledge. I think your talk was perhaps mentioning that. Did
That's the thing that you want to avoid, yeah.
Yes.
And I thought that some questions, at least I don't see how they can be resolved by mathematics. It's more a question of feeling. Yes. One thing you see in the newspaper is conflict between the US and Iran. Well, mathematics is what you think about it, but should Iran have a nuclear program? Well, you could say yes, or other countries are. We need an equality among the countries. You could say also, well, the ultimate plan is to get rid of atomic weapons, to have a more peaceful world. So in such a case, why to have more?
Indeed.
How can mathematics can help in that? This is an important question. I don't put an answer one way or another.
Yes, in fact, Bausha has a question which he wrote to me in the chat. Bausha, would you like to say your question? Bausha, are you there?
Yes, hello.
Yes, do
hello.
you want to put your camera on as well?
Okay, just 1 second, I'm sorry, just to see whether this works.
Yes.
Yeah. Hello everyone. Yeah, and thank you for this presentation. So I would just like to pose this question, since I'm from a legal field, so I'm not that close to science, but I'm very interested in how science can deconstruct the complex social phenomena. So my question was, and I will read it as I wrote it to Mirna. So let's say that humans are influenced by social constructs of various kinds. In that sense, what was unacceptable several decades ago, in example, women voting, is now unquestionable. And vice versa, what was completely normal in the 60s, in example, human zoos in Brussels, is now unimaginable. So the question is how science, complex as it is, observing the natural regularities, can deconstruct such a complex issues regarding the social construct. So how to approach these social phenomena that are full of irregularities? That is my question as someone from completely outside of the science.
Yeah.
Thank you.
I'm not sure how science can help in that. It's more common sense which can help on these things. Maybe science, but with common sense.
But if science cannot help, what can help?
Yeah, my first
sense of honesty. Like Manhattan said, there's some limitation of what science can do. And I think it's not so much a rational question. You can say, should women vote? That was the example you put.
No, my
of course, I think so. But that's it. It's not really. I don't see a scientific answer to that.
My idea was just that social phenomena are full of irregularities, maybe irrational, irrational paths, or the. So in that sense, something that we were taught, at least during the education where we had where I had mathematics and physics and science. It is purely rational. Maybe I'm wrong, but I'm just asking, and I'm sure that mathematical modeling could help in deconstructing the social phenomena. But I'm just interested in how to tackle it, since it is so unpredictable, so irrational, and so
maybe by showing mathematically that it is something irrational, showing that there is no definite answer. Like
Yes.
if you have a theory that having more and more atomic weapons is going to produce a stability, I don't think it would have to be a very wicked model to come to that particular conclusion. There must be a threshold after some on which the situation gets unstable, because you increase.
So you're suggesting to construct a model which would show that what we think is irrational actually is irrational.
Yeah, maybe, yeah.
Well, actually, my talk will be about some historical examples of that. I will be talking about Condorcet, who did exactly that in order to convince the French Revolution to drop the slavery.